Hello, my name is Tirtza Zahavi, and I'm presenting this lecture on behalf of many friends of mine. I work in the Extension Service in the Ministry of Agriculture as a viticulture specialist, and with me work Eran Arkabi and Eyal Rabban. And we did this project together with people who are more soil people, Nurit and Moti and Ephraim. And very sorrowfully, Yoni Gal, who actually started the project and worked in the extension service, passed away in 2015. So this is, in a way, on behalf of him and in honor of him. And we remember him not every day, but every few days we do. So I will start with the lecture itself. I want to start talking a little bit about Israel. I don't know how much you heard about Israel already and about Israeli viticulture. Israel is small. It's 420 kilometers long. The widest area, the widest place is 100 kilometers. But in this very small place, we have from more than 1,000 meters above sea level to less than 400 meters below sea level near the Dead Sea. And we grow vines in all of these areas. We grow table grapes, about 350, 100 hectares of table grapes, mostly, of course, are seedless grapes, and about double this area with wine grapes, mostly international varieties. All the vineyards are irrigated, all have drip lines installed and fertigation systems. And in table grapes, we irrigate something between 250 and 1,000 millimeters a year, of course, depending on the exact place of the vineyard, while some of the wine grapes are not irrigated at all, and some go up to even 350 millimeters a year. The last thing I want to show on this map is concerning the project that I'm going to present. It's the places where the two vineyards where we did the experiment that I will show. One in the very high in 1,000 meters above sea level up in the north, and the other one is in the center of Israel about 100 meters above sea level. What was the project? What's the reason for the project? If we look worldwide, protocols for leaf analysis of grapevine there are many, and they differ in three parameters. One is the timing. When is the best time to take it? And that will be one possibility is full bloom. The other possibility is veraison or veraison. For those of you who are not viticulturists, this is the time when the berries start to mature, where the berries start to change color and start to accumulate sugar. That's the second time that is used in some places. And the third time is just before harvest or a few weeks before harvest, when berries are around 21% sugar or bricks. So timing is one issue. The other issue is the plant part to use, whether it's petioles or blades. And then when we take the samples, the question in the lab is whether to use aqueous extraction or acidic digestion. Because there are so many protocols, extension people like myself, lab people, winery people, each choose its favorite method. And therefore, there is no common standard or no common language when people talk to each other. You have to ask, what did you use? When did you use? How did you do the analysis? And our aim in this work was to find the ultimate protocol that will reflect differences between fertilization treatments and between fertilization status of the vines. Of course, we didn't have a lot of money to do the experiment. So what we did was to choose vineyards, two vineyards, but we looked for vineyards that have two identical parcel or blocks. So when I say identical, I mean the same planting material, of course, the same year of planting and the same treatments up when we started the experiment. And these two blocks, two parcels that were in this vineyard, in the vineyards that we used, each one was used for one fertilization treatment. And the fertilization treatments we had where one was high fertilization and the other low. And we had, as you remember from the map, we had a north vineyard, a northern vineyard, and a southern vineyard. The experiment went on for 9 years here and for 7 years in the southern vineyard. And the amounts in both treatments got nitrogen every year. These are the amounts, kilograms of mineral per hectare per year. So nitrogen was applied in both, but more than double in the high treatment compared to the low treatment. Phosphorus was only, and potassium were applied only in the high treatment, while nothing was applied in the low treatment, again in the two vineyards. And what we did, we applied the minerals, and what we did was to sample petioles and blades in the three stages, three developmental stages of the vines each year, and to analyze them in the lab in different nestlings. So, as a result, we are looking at three macro elements, okay, NPK, two fertilization treatments, and each of them was repeated in three replicates or subplots. This was done, as you remember, in two vineyards for between 5 and 7 years. And each year we had three phenological stages, like you see here, bloom, veraison, and close to harvest, two plant parts, petioles and blades, and two lab methods, either aquatic or acidic extraction. And this is a sample of results we have from one of the sampling of the testing in the lab. This is nitrogen as nitrate, as NO3, okay, in petioles in the northern vineyard. All these results are from one vineyard. And we see the different years. And each year we have three sampling dates. The early one is the bloom, then veraison, and then harvest, okay? And you see this repeats itself every year. And the high fertilization treatment is always in the gray, okay, in the gray square, and the low fertilization in the red square. We can see that in some of the years, we had very nice results, very nice differences between the high treatment and the low treatment in the three dates. You see here, again, flowering, veraison, and harvest, and the three, in all three stages, they differ. Okay, but in other years, it was not so clear. You see here that the differences are very small and of course not statistically different. We had to look and to sum up all of this data. And for that, we organized the first table. And this table includes, it's talking about, again, the same thing, NO3 in petioles, in the southern vineyard and the northern vineyard, in the three stages, high treatment, low treatment, all the years of the experiment. And I marked in red the years where the values for the low treatment were lower than the values for the high treatment, okay, like we see here. On the other hand, you see here, when it was not marked, that the levels are actually nearly equal and even a little higher in the low treatment. We see here that NO3 in petioles was very nice because most of the years, most of the ways we tested are marked in red. On the other hand, if we look for nitrogen in blades, we see that there are very few red markings, which means that this system was less good, or this method was less good than the first one we used. In order to look at all the data we have, I mean, this was only for nitrogen as NO3 if we want to look at all the data and all the years together, we had to come up with a more concentrated results. And Nurit came up with the idea of the success index. Success index means for each phenology, for each stage of growth, and for each plant part, and for each lab method, what is the percent of cases out of the years of the experiment in which the analysis fit the treatment. And that means that the low treatment value was lower than the high treatment value. And of course, I'm talking about low and high, I mean statistically different. And this way we could put actually all the data in one table, and you see the marked with yellow or with green. We mark the percentage of successful result. And we can see for nitrogen that 83% of the cases of the southern vineyard had good results when looking at NO3, at variation, in all the areas, okay? For phosphorus, only petioles in acidic digestion got quite okay results, and this is also only in the southern vineyard, and we shall relate to this, I will relate to this later. On the other hand, with potassium, you see again that most of the methods gave quite good results, but we had to choose, of course, a way of testing which repeats itself in the for the different minerals, both for phosphorus and potassium. If we could, it would have been better if it could be also for nitrogen. So here we chose the ones that repeated themselves the most, the highest success index. And for that, we had the winner from this last table, and we found the testing in petioles was the best. Testing at Verizon was better than bloom time or the harvest. And for the lab method, we had to use aqueous extraction for nitrogen and acidic digestion for potassium and phosphorus. Actually, this is the end of the work, but I still want to mention one thing. You remembered, and I mentioned it, that we had very big differences, both for phosphorus between the South Vineyard and the North Vineyard. You see here, nice number, 67% of success, while in the Northern Vineyard, nothing. And for potassium, Southern Vineyard, very, very low levels, while in the North, we had nearly 100% of success. And when we looked, the reason for that was the status of the soil. Okay, you can see in the brown square here and here, the soil potassium. You see the big differences between the Northern Vineyard, which had very low potassium levels, and the Southern Vineyard with high potassium level. And where we have high potassium level, there is no reaction to the fertilization treatments that we applied. And the same thing with phosphorus in the Northern Vineyard, which is again high, no reaction for the phosphorus in here. So we think we have the winner. We think we have the right way to check, to test for minerals in the vineyard. And I think we did for us, we had a good work. And I want to thank you for listening, and the Israeli Wine Board who financed the project. Thank you very much.